Hi, welcome to lesson 22I, Laws of Probability. Today the goal of the lesson is going to be to learn how to use the laws of probability to determine probabilities. So we've looked at a few different techniques for calculating probabilities using Venn diagrams. Recently we looked at tree diagrams just previously before that. Now we're going to take a look at a few laws which I've already kind of touched on, but we'll just kind of review them right now. So there's a few things. Some different events are called, have different names. So for example, mutually exclusive events or disjoint events, they have no outcomes in common. So for example, if I were to use a Venn diagram for this, I would say that if event A, we've got some sort of event A occurring and some sort of event B occurring, event A and B would have no events in common, no elements in common. So these are events that cannot occur at the same time. For example, if I were at the end of a street, I'm driving along, I'm at the end of the street, I can either turn left or I can turn right. I can't do both. Flipping a coin, you can either have heads or tails. You can't have both. If you're rolling a die, the number that comes up will either be even or odd. You can't have both. Okay? So the probability of event A occurring or the probability of event B occurring is going to be the probability of event A plus the probability of event B. Okay, so the probability of one of those two events occurring will be the sum of the probability of event A and the probability of event B. So that's how we would calculate the union of mutually exclusive or disjoint events. Okay. If we look at non-mutually exclusive events, these are events that have some sort of outcome in common. For example, drawing on the Venn diagram, we've got event A and we've got event B. We would see that there could be some outcomes common to them. So for example, if we're say watching TV and eating, both of those things can happen at the same time. Or reading a book and drinking coffee, obviously that can happen at the same time. If you were to roll a die, a number could come up to be odd and a prime number. So for example, the number 3 is both odd and prime, so that could happen at the same time. So the probability for non-mutually exclusive events of event A and union B would be the probability of A plus the probability of B minus the probability of the intersection. This is how we would calculate the union of this, because if we have the probability of event A occurring, we've got all of this part of the circle, and if we add the probability of event B, we've got all of this. Well, notice that we've counted this part in here as part of event A, and we've counted this as part of event B. So we're counting that overlap twice. So we can only count it once, so we have to subtract one of those away. So we're subtracting off the intersection of those two one time, so that we're only accounting for it one time. Then there's the case of independent events. And independent events are when the occurrence of one event or one outcome does not influence the occurrence of another. For example, rolling a die and flipping a coin. The outcome of the die has no influence on flipping the coin. Or if we were to flip a coin multiple times, the fact that we got a head on the first flip, for example, does not influence the next flip of that same coin. We could also have, for example, event A being that the first flip of the coin is a head, and event B could be that the second flip of the coin is a head. Okay, I don't need this bracket there. So these are the two possible events, and so event A, the sample space would be head and head, because that's the first flip is the head, or we could have head and tail, if we're flipping the coin twice, of course. So the first flip is a head. Event B is head and head, because the second flip is a head, and the next is tail and head, where the second flip is a head. So in this case, these are independent events, and there can be an overlap. Okay, so we can have head, head here, and in event A we've got head, tail, and event B we've got tail, head. Okay, but event A and B are not mutually exclusive, even though they are independent. Okay, so this is the case, one of the many, many cases where that could occur. Okay, we also have conditional probability, where given that one event has occurred, we want to find out what the probability that another event has occurred. Okay, so we can see this as conditional probability A given B is written like this. Okay, meaning that event A occurring given that event B has already occurred. Okay, so the probability of that, A given B, is, and I'll show you this in a second, the probability of A intersect B divided by the probability of B. Okay, so if I were to draw a quick little Venn diagram here, and we've got event A here and event B here. If we're saying what's the probability of event A occurring given that B has already occurred, so what we're saying is of all the elements of B, of all of these, so this is, we already know this is occurring, so B is already going to occur. Of all of these outcomes of B, which ones are also in A? And in that case, that would be this part here. Okay, so that's how we get this intersection, the probability of A intersect B. So of all the, so we already know, given that B has occurred, how many of those are also in A? So that's the intersection. And then we divide that by the probability of B occurring out of the full universal set, because we want to see what the probability of this intersection of the whole universal set. Okay, so we're going to be looking at a few examples of all of these things tomorrow in class. In the meantime, what I would like you to do, of course, as always, is take a look at examples 21 and 22 on page 597. Then example 23 on page 598. Then take a little peek at the sample exercise or the practice exercises on page 598, numbers 1 to 3. Followed by looking at examples 24 and 25 on page 599, and of course, as always, listening to the self-tutor for all of these, and then looking at exercises 6 through 8, 10, 12, and 14 on page 600 to 601. Again, you'll have time in class to work on these. If you would like some extra insight on mutually exclusive and independent events and conditional probability, take a look at these videos, the video links that are going to appear down here at the bottom. These are from a community college, I think somewhere in the States, and they also have an excellent, they give an excellent insight and explanation of what these events are all about. Okay, so thanks for watching, and we'll see you in class.